Hi guys, welcome to Science Chomp. Today we're going to be looking at equations of motion. Now I've got everything all laid out. You've basically got four equations. Vf equals Vi plus At, x equals Vit plus half At squared, Vf squared equals Vi squared plus 2Ax, and x is Vi plus Vf over 2 times t. Now all of these letters are represented over here. So t is time. The two V's, that's velocity, so initial velocity, final velocity in meters per second. X is displacement in meters, and A is acceleration in meters per second squared, or meters per second. Now the idea behind solving equations of motion is you write down everything that you know about the question. Like, so for example, if you've got VF, you write down VF. If you've got A, you write down A, etc. And what you should have is basically all of the ingredients to solve at least one of these equations with obviously one unknown. And then from there, you solve your question. So let's have a look at 5 different examples. And basically that will give you everything that you need to know to solve these things. So this is my worksheet. Okay. The first one says, if a car accelerates uniformly at a rate of 5 meters per second, how long will it take to reach a speed of 30 meters per second starting from rest? So A is equal to 5 meters per second. We want to work out t, so t is an unknown. Starting from rest, which means Vi is equal to 0 meters per second. And that's all we have. So we got acceleration, Vi, and actually Vf, they tell us, Vf, which is 30 meters per second. So what we need is an equation with Vi, Vf, A, and T, and we're solving for T. So let's have a look at our equations. Okay, and it looks like it's going to be the first one. We got Vi, we got Vf, we got A, and T is our unknown. So let's try to solve this together. So Vf equals Vi plus At. Now since Vi is 0, we can basically get rid of that. So Vf equals A times T. And if we rearrange this, let me just write that in full. A times T. Because that's A times T, if you take this to the other side, it becomes an opposite. So it becomes, instead of times, it becomes divide. So you end up with Vf divided by A is equal to T. So let's put that in. Move this out of the way. And T, let's just write it again. Vf is 30, A is 5, and then 30 divided by 5. If you're unsure, use a calculator, which is 6 seconds. Very easy. Okay, that's the first question. We'll do a few more examples. Our second question is this. It says a mouse starts at rest. Rest means Vi equals 0. And accelerates to 3 meters per second in 4 seconds. So Vf is 3 meters per second. And it takes 4 seconds. That's your time. And what is the distance the mouse travels? So we want to work out x. Okay, so we've got Vi, Vf, T, and x. So let's figure out exactly which equation that we need. So this is a tough bit which a lot of students have trouble with, is figuring out which equation. So we can't have this one because this has got A and we don't have A here. Can we use this one? No, because that has A as well. What about this one? Well, we have Vf, we got Vi, A we don't have, so you can't use any of the first three, so it's got to be this one. Let's have a look. We've got VI, VF, T, and we need to find out X. So that's our one right there, the one at the bottom. So let's write that out over here. So X equals VI plus VF over 2 times T. No rearranging required here, you just put the numbers straight in. So 0 plus 3 divided by 2, so that's basically 3 divided by 2, times T, which is 4 seconds. So that's 3 divided by 2, that's 1.5 times 4. And then you get your calculator out. 1.5 times 4 is 6. And because it's displacement, it's 6 meters. Very easy. Let's go into question number 3. So I'm going to do the same thing as before. Every time I find something out, I'm going to write it down and we'll go from there. So a ball is dropped from rest. Rest means VI is equal to 0. The acceleration due to gravity is 9.8 meters per second squared. So 9.8 meters per second squared. It takes 7 seconds to hit the ground. So time is 7 seconds. What is the final velocity before it hits the ground? So we want to work out VF, and that's our question mark. Okay, so we've got VI, we want to work out VF. VIAT VF, let's have a look at our equation. Okay, so VIAT VF, VIAT VF, the first one, perfect, perfect. We don't even have to rearrange anything, it's always set for us. So let's just put it right in there. So VF equals VI plus AT. Now the thing is, because VI is 0, you can basically just cancel it out. So you've got VF equals AT, that's A times T. Acceleration is 9.8, time is 7, so 9.8 times 7. Get your calculator out. Should be just under 70, isn't it? So 9.8 times 7 is 68.6 meters per second. Extremely easy. Question number 4. Okay, so this says, if a ball is dropped from rest, so again, rest means VI equals 0, and falls 8 meters to the ground, so X is 8 meters. What is the final velocity before it hits the ground? VF we don't know. And acceleration due to gravity is 9.8 meters per second squared. VI, X, VF, and A. Let's figure out which equation. Okay, so is it this one? No, because we don't have T, we can't use that one. Possibly this one, let's have a look. So VF, yes. X, yes. VI, yes. A, yes. So it's going to be this one. VF squared equals VI squared plus 2AX. Let's put this over here. So VF squared equals VI squared plus 2AX. 0 squared is going to be 0. Okay. So you can cancel it. 2 times 9.8 times X is 8. Okay, remember this is for VF squared. So let's work out what VF squared is. Again, we can ignore that. 2 times 9.8 times 8, which is 156.8. Now this isn't the final answer because this is for VF squared. Now, if you want to work out for VF, what you've got to do is you've got to square root 156.8. Okay? That's square rooting is basically doing the opposite of squaring something. So let's do that. Square root of the answer, which is 12.52 meters per second. Smashing. Got one last question to go. So let's do this. Okay, so a cyclist traveling at 7 meters per second. So now VI is 7 meters per second. Accelerates, and then accelerates at 2.5 meters per second squared. For time, is 12 seconds. How far did you travel? Okay, so we've got VI, AT, and X. Let's have a look at our equations. Okay, so we've got VI, AT, and X. It's going to be the second one. So we've got VI, we got T, we got A, and we want to work out X. So we don't need to, rearrange it. So VIT plus half AT squared. X equals VIT plus half AT squared. VI, that's 7 times 12 plus half times 9.8 times 12 squared. All right, let's do this. Again, let's get the calculator out. Now, luckily, I'm quite good at maths. Actually, I'm hopeless, but that's 144. 9.8 half 7 times 12. You see, I can't even do that. There we are. So 7 times 12 equals 84 plus half times 9.8 times, I'm going to put 12 squared in case that's a mistake, which I doubt, but anyway. 705.6, so I'm going to add those two together, plus 84, which is 789.6 meters because displacement. And there we have it. That's how you do equations of motion. Again, what you've got to do, make sure you write down all of your variables first, and then pick the equation which has all of those variables. Thank you very much for watching, and goodbye.